Right now, somewhere in a data center, a hard drive just failed. And without redundancy, millions of files could be gone forever. This happens thousands of times every single day. And here's the deeper problem nobody talks about. Everything we've ever recorded is rotting. Your photos, our history, government records, financial systems. Almost all of it lives on hardware designed to fail within a decade. But inside this lab is a piece of glass that doesn't decay, doesn't need power, and, according to materials science, could remain readable 13.8 billion years from now, longer than the universe has existed. It's called a memory crystal. One disk can store up to 360 terabytes, survive extreme heat, and sit untouched. Here's the problem nobody talks about. We're drowning in data we can't afford to lose, but barely ever for centuries. A trillion-dollar tech giant is betting hundreds of millions of dollars that this is the future of data storage. And a tiny UK startup is racing to get there first. Everything. Between 60 to 80% of all global data is what's called cold storage. You almost never touch it, but losing it would be catastrophic. For access. Governments, hospitals, banks, research institutions, everyone hoards, and here's the uncomfortable truth. The technology storing this data is failing, constantly. Media. Then copy it again, and again. An endless migration cycle that burns massive energy, chews through hardware, and costs a fortune, just to keep unchanged data alive. From a sustainability standpoint, it's a nightmare. From an engineering standpoint, it's unsustainable. Enter glass. Not just any glass. Memory crystals made from fused silica that store data as physical nanostructures inside the material itself. Hard drives? Dead within 5 years in most data centers. Magnetic tape? Lasts longer, but it still degrades. So what do? We copy everything to new. Two players are leading this revolution. Phonox, a UK startup spun out of the University of Southampton in 2024, and Microsoft, which has been quietly developing Project Silica since 2016. When a university spin-out and a trillion-dollar tech giant independently arrive at the same solution, the current system is definitely breaking. Let's start with the more aggressive claim. Phonox has developed what they call 5D glass memory crystal technology. Here's how wild this is. They use femtosecond lasers that pulse in millionths of a billionth of a second, to write data inside a 5-inch disc of fused silica glass. A single disc can store up to 360 terabytes. For context, that's about 72,000 high-quality movies on something the size of a drink coaster. Once the data is written, it requires zero power, zero cooling, zero maintenance. It just sits there, locked inside the glass. And then comes the claim that sounds physically impossible, 13.8 billion years of data. But here's why that number isn't marketing hype. It's material science. Stability, the age of the universe itself. Fused silica glass has no known internal decay mechanism at room temperature. It doesn't demagnetize like hard drives. It doesn't leak electrical charge like flash memory. It doesn't chemically degrade under normal conditions. If the glass stays physically intact, not shattered, not melted, not lost, the nanoscale structures written inside should remain unchanged for timescales comparable to the age of the at once. Store forever. The technology is called 5-dimensional optical data universe. This is why Phonox calls it storage. Data is encoded as tiny nanostructures called voxels inside the glass. Each voxel has 3 spatial dimensions, x, y, and z coordinates, plus 2 optical properties, orientation and intensity. Those 5 independent parameters allow enormous amounts of information to be packed into a tiny physical volume. Reading the data involves shining polarized light through the glass and using optical systems to detect how the nanostructures interact with that light. Software reconstructs the original data. because information is stored as physical structure rather than magnetic fields or electrical charge. It's naturally resistant to heat, radiation, water, and electromagnetic interference. Phonox didn't invent this overnight. Researchers at Southampton have been developing this technology for over a decade. The first successful 5D data recording in glass happened in 2013. 5 years later, in 2018, the technology made global headlines when a 5D data crystal was launched into space aboard SpaceX's Falcon Heavy, the same mission that sent Elon Musk's Tesla Roadster into orbit. That wasn't a publicity stunt. It was a durability test. Now here's where it gets current performance. Write speeds around 4 megabytes per second, read speeds roughly 30 megabytes per real. Phonox says they'll be ready for actual data center pilots within 2 years. Second, by modern standards, that's painfully slow, and Phonox admits it. But their argument is elegant. Cold storage doesn't need speed. It needs reliability and long. Phonox has published a roadmap targeting 500 megabytes per second for both reading and writing within 3 to 4 longevity. For archival data, access latencies of several seconds are perfectly acceptable if the data is guaranteed to survive. Years. Early system costs are estimated at about $30,000 for a writer and $6,000 for a reader. They've raised around $4.5 million so far and claim they're moving from technology readiness level 5 to level 6, transitioning from controlled lab validation to real operational environments. While the UK startup pushes aggressively toward market, Microsoft has been working on the same idea from a completely different angle and for much longer. Project Silica began around 2016 inside Microsoft Research, driven by one sobering realization. Magnetic storage simply cannot scale sustainably with the exponential growth of cloud data. From day one, Project Silica wasn't designed as a standalone storage experiment. It was built as a cloud-native archival system specifically for hyperscale data centers. Microsoft went beyond lab demonstrations. In a widely cited real-world test, they partnered with Warner Bros. To store an entire Hollywood movie on glass. The film? Superman. They chose it specifically because it represents a large production-grade dataset rather than a synthetic test file. Microsoft encoded the entire movie into a quartz glass plate, stored it, and later retrieved it with zero data loss. But Microsoft's demonstrations go further. They've publicly shown that data stored in glass can survive boiling temperatures, extreme heat, full water immersion, surface scratches, radiation exposure, and electromagnetic pulses, all while remaining readable long after hard drives or magnetic tape would fail. Project Silica is built around robotic archival libraries where glass plates sit on completely passive shelves requiring no power, no cooling. What truly separates Microsoft's approach is system-level design. No electronics. All the complexity is concentrated in the robots and readers. When data is requested, a robot retrieves the specific glass plate and brings it to a reader. The rest of the time, the archive consumes almost no energy. Cycle. Write once, leave untouched for decades. There's also a security angle. Because the glass contains no electronics and requires no power to retain data, it's inherently air-gapped when Microsoft describes this as eliminating the endless data migration stored. That makes it immune to ransomware, remote cyber attacks, and persistent malware. A massive advantage for governments, national archives, and regulated industries. Rather than advertising billion-year lifetimes, Microsoft communicates more conservatively, thousands to tens of thousands of years. This reflects enterprise risk modeling rather than a limitation of the material itself. The underlying physics of quartz glass remains the same. Project Silica is intended to become a future component of Azure's cold and archival storage APIs while the storage layer quietly shifts from magnetic media to glass. tiers, where customers interact only with cloud. So here's where we are. Microsoft has scale, capital, and infrastructure. Total investment is well north of $300 million, potentially approaching $500 million over the project's lifetime. If glass storage becomes a mainstream cloud service, Microsoft is positioned to dominate. Phonox, however, isn't trying to build a cloud storage service. Their strategy is to license the glass media and optical read-write platform into existing data center architectures. That makes them a potential infrastructure supplier rather than a cloud competitor, a fundamentally different play. And they're not alone. Other startups like Cerabyte are developing non-magnetic laser-written storage using ceramic materials, reinforcing the idea that the industry is actively searching for alternatives to tape and hard drives. Both approaches face the same hard limit: physics. Writing data into glass means physically forming nanoscale structures with lasers. That process cannot be rushed without losing precision. Reading the data back requires careful optical scanning of those structures, which also takes time. Faster computers can help with decoding, but they cannot remove the need to physically write and scan the glass. This is why glass storage will never be fast or interactive like SSDs. It's designed to trade speed for durability, energy efficiency, and glass storage isn't meant to replace SSDs or hard drives, it's meant to replace tape and long-term permanence. This is infrastructure for long-term archives, not everyday use, and that trade-off is exactly the point. The next 2 years will determine whether the UK startup's aggressive push reaches deployment before the tech giant's magnetic archives, the most invisible yet most critical layer of the digital world. Careful system-level rollout. Either way, the implication is the same. For the first time in the digital age, humanity may have a realistic way to store information longer than civilizations last. Investment. Who actually wins? My bet? Both do. Phonox licenses the tech to everyone who isn't Microsoft. Microsoft builds it into it. So here's the question. A 2-year startup claim versus a decade of Microsoft research and $500 million in Azure. And within 5 years, your most important data is sitting in glass somewhere, outlasting everything. The question isn't if glass storage happens, it's who controls it when it does. Silk Route. If this video added value, like it so it if you care about long-term AI and semiconductor breakthroughs, not trends, but the infrastructure, physics and bottlenecks that decide what actually scales, this is what we do on Quantum. Reaches the right audience. Comment below with your take. Is glass storage inevitable, or does magnetic media still have a future? And if you know someone working in AI, data, or semiconductors, share this with them.